create an interface tutorial, open Materials Designer, by navigating to the Materials Collection page. Then, open the Input-Output menu, and import a sample structure of crystalline gold, which will be added next to the existing sample of silicon. This structure can readily be imported from the materials bank, if it is not already present in the materials collection. Then, open the Surface Slab menu option, in order to create a silicon slab. First set the Miller indices to 211, then, set the number of layers to 6. The vacuum ratio to 0.44, and the supercell dimensions to 2 by 2, to create the corresponding slab. We now repeat the same procedure for the case of gold, to create its corresponding slab. We use the same slab parameters, with the exception of the XY supercell dimensions, which this time we set to 3 by 3. Next, we need to slightly strain the gold slab away from its equilibrium lattice configuration, in order to ensure a better matching between the two crystal structures across the interface. Now, open the View menu, and then navigate to the Multi-Material 3D Editor option listed there. We will use this new editor interface to combine the gold and silicon slabs together, so as to generate a unified interface structure. First, let us adjust the vertical distance along the Z dimension separating the top gold slab from the bottom silicon one. By inspecting the relative Z coordinates of the gold and silicon atoms respectively, we achieve in this way a total separation of about 2 angstroms across the interface. Next, we reorient our view of the system first laterally and then vertically down, and we take care to verify that the two slabs are properly aligned with each other. Once this is done, we exit the Multi-Material 3D Editor via the top left menu, in order to return to the original Materials Designer interface. As a result of our manipulation, a new material has therefore been added to the list on the left-hand sidebar, corresponding to the combined two slabs interface system. Let us inspect the structure of this combined system via the interactive 3D viewer. Bonds can also be added and drawn between the atoms within the crystal structures, via the relevant option of the 3D viewer. We now rename the new material structure to a more memorable form, such as Interface Silicon Gold. Then, we save all structures under consideration simultaneously to our collection of materials, via the relevant option under the Input-Output menu. Finally, we exit the Materials Designer interface, again via the Input-Output menu. As a result, we are able to retrieve, within our materials collection, the individual structures for the silicon and gold slabs respectively, as well as for their combined interface structure. This completes the present tutorial.